Augmented Reality and Virtual Reality Part 2. This is Dr. M. Prakash, Professor from the Department of Mechanical Engineering. In the Module 1, the Part 1, what we have to complete the various content related to the introduction of Augmented Reality is the definition and scope of an Augmented Reality, history of an Augmented Reality, examples of an Augmented Reality. And along with that, the displays and multimodal displays, visual displays and projected displays also going to be discussed. In detail about the visual perception, which is really required for getting to know about the object, what we have to study through the augmented reality is going to be discussed in detail, and furthermore detail is also going to be discussed here. The key elements of visual perception in augmented reality is depth perception, spatial perception, motion perception, and then color perception and visual attention. In detail about individual perception is going to be studied here, and the depth perception in augmented reality is the depth perception helps the users to estimate the distances and understand the 3D structures in the real world enhanced by the virtual objects, and it allows the AR system to deliver the realistic, accurate and immersive experiences by mimicking how the human eyes and brain precise the depth. Our brain combines the visual content to the depth of accuracy in that nature, and the various techniques are used here is stereoscopic vision, motion parallax, perspective projection and shadow rendering. What is stereoscopic vision? Each eye sees the scene of an from slightly different from the various angles. The brain combines both the images to precisely interpret manner. Imagine that our left eye and right eye are going to be measured a simple object in a different depth of perception, and the key aspect of the future can be identified by the brain. So the key benefit is the accurate depth perception and 3D understanding about the objects. Another one is called as motion parallax. When the user or object moves, nearby object appears to move faster than the distance objects. So the near objects move more than far objects is going to be identified by the motion parallax. Another one is called as perspective projection. The parallel line appears to converge. The parallel line appears to converge at a point of the distances of an object. Here the convergence going to take place. The object gets smaller and they are far away from that. This is called as a vanishing point, in which the image is going to be taken as the perspective in nature. The last one is called as a shadow rendering, in which the shadow gives the clues about the position, height and distance. You know that the light source from the sun is going to be change the direction of the shadow, which will indicating that location of the light. And similarly, the object is going to be identified from the fixed light sources, and the distance and everything can be marked very easily. So that you need to be know about the clearness about the particular objects. So how the depth perception enhances the AR experiences. It will giving the better distance in estimations, realistic 3D interaction, accurate object placement and reduced cognitive load, and then stronger immersion impression. So what is the reduced cognitive load means? To identify the object what it is. So we need to be discuss and analyze among yourselves to know about, get to know about what type of object it is, and that can be reduced by means of the clear image perceptions. So in terms of an application, it is used in medical, industrial and navigation system. Each one of them have the uniqueness in their respective field, and visual organs and structured 3D can be known by this the depth perception in terms of an accurate modeling of 3D objects. So from this we can able to take that the depth perception is the foundation of a realistic augmented reality. By using visual cues such as stereoscopic vision and motion parallax and perspective projection and shadows, an AR system can accurately represent the 3D space, leading to the better understanding, safer interaction and highly immersive experiences. Now, we need to take what is the detail view of spatial perception. The second perception is a spatial perception. The definition about the spatial perception is in augmented reality refers the ability to the user to understand the position, orientation, distance, movement and relationship of an object within the three-dimensional environment. It enables the AR system to place the virtual objects naturally into the real world so that the user perceives them as a part of physical environment. Imagine that it is a physical environment. The core concept of the spatial perception is the spatial perception helps the user to answer questions such as where is the object located, how far it is from here and from me, which direction it is facing, is it moving or not, how does it related to the another real world objects. So the technical supporting for the spatial perceptions are SLAM, that is simultaneous localization and mapping. It's mostly used in environmental mapping. And LIDAR sensor, it can be used the depth sensing. And computer vision, it identify the object recognized. A algorithm, scene understanding, depth cameras, distance measurement. And the working principle related to the spatial perception in AR is here, the first one is environmental sensing, the second is spatial mapping, and third one is position tracking, the fourth one is object registration, and five is a real-time interaction. In the first one, the environment going to be scanned by means of the camera, depth sensor, lidar sensor, or by using the GPS system. And spatial mapping related to the wall, floor, object, the surface can be segregated by means of spatial mapping. And position mapping tracks the user movement, head orientation, device location, everything. It most probably using the various sensors like accelerometer, gyroscope, and computer vision. And for object registration, the virtual objects are anchored to a real-world coordinator. The real-time interaction can be happened by means of the system continuously updates the object position and orientation based on the user movement. And the most technology which are used here similar to the last one, it can be a SLAM, LIDAR, computer vision, AI algorithm, and depth camera. The detailness about that is also going to be known from the systematic pictures from here. So the SLAM is going to be give the simultaneous localization and mapping, the environment mapping by building a map while tracking the device locations. And uses laser the scanning to measure the distance and generate accurate 3D points by using a LiDAR sensor. In a computer vision, it will identify the object, features, and patterns in the real-life environment. AI algorithm understands the scene, predicts depth, detects object, and improves the decision making. So these are the working principle of the spatial perception in augmented reality. What is the application in spatial perception? The spatial perception application is while it can be used in many of the field, starts from the healthcare to the defense and orientation, because it giving the accurate results about the objects being presented in the real life environment. The healthcare is the surgical guidances, real-time 3D overlay guides the surgeons during the operation, and an anatomy of the visualization, view 3D models of an organ and structures in real-world environment. Especially in manufacturing, the machine assembly assistance, AR provides the step-by-step guidances for accurate assembly. It will generating the maintenance support, visual interaction, and part information help the technician to perform the maintenance effectively. And finally, we go for an automotive, the navigation systems. AR overlays the real-time navigation direction on the real world. It can give the driver assistance, provide the spatial alerts, land guidances, and obstacle detection. In terms of education, it's purely on interactive session oriented. The people may have that realitical nature of an objects, what we are trying to educate and learn from them. Defense, its battlefield visualization, AR displays the terrain, enemy position, and mission data in the real time. Situation awareness is going to be generated by means of enhanced awareness of the surrounding. And in Industry 4.0, for evolution of Industry 4.0, the spatial perception in augmented reality is used in many applications like digital twin, smart factory visualization, human robot collaboration, and remote maintenance. Now we move on to the third perception, which will be called a motion perception. The motion perception in augmented reality refers to the ability to the user in AR system to detect, interpret, and respond to the movement in both real and virtual environment. It enables the user to perceive the object movement, user motion, direction changes, speed variation, gesture-based interaction. Motion perception is essential for creating immersive, interactive, and realistic AR experiences. In AR system, motion perception helps track the moving objects, synchronize the visual content, maintain the real-time interaction, improve the spatial awareness. And the importance of the motion perception is it will creating the real-time interaction, enable the dynamic AR experiences, and for object tracking, tracks the movement accurately and gesture recognition detects the hand body motion, and immersion improves the realism, and navigation supports the movement guidances. These are the technologies are used along with that what we are used in the spatial perception. It also integrated with accelerometer and gyroscope because of the motion going to be monitored by the sensor, and the sensor data going to be used. The technology used a computer vision, it will creating the motion analysis, AI algorithm which going to give you the movement predictions, and accelerometer, linear motion sensing, gyroscope, rotational motion tracking, and lidar depth and movement detection, SLAM, real-time environment mapping. So, in terms of working principle in motion perception, it starts from the step 1 is a motion detection, step 2 is a motion analysis, third one is a tracking, fourth is a motion prediction, and the fifth is a real-time rendering. Similar to the spatial perception, here also we are using camera, accelerometer, gyroscope, and depth sensors, and motion analysis identifying the direction, speed, orientation, and position changes, and tracking is indicating the user movement, head movement, hand gestures, and then object motion, and motion prediction identifying the whether it is past and predictive mode. The system predicts the future movement to reduce the latency and improve the smoothness of the objects. And real-time rendering, visual content updates instantly according to the motion. So it also indicating the spatial perception of an individual objects. The various components used in the motion perception is motion tracking, head tracking, gesture recognition, and object motion detection. So in motion tracking, users, devices, and objects is using the optical tracking, inertial tracking, and sensor fusions. In a head tracking, it is used in the various gadgets like head orientation, viewing direction, position with the help of AR headset or smart glasses and navigation system. And for gesture recognition, it will need a hand, finger, and body gesture. So we need gesture camera, AI vision system, and infrared sensors. And object oriented, it may be an example of vehicle movement, mechanics, and human movement. So the technology, whatever we studied in the earlier slide, is also going to be in detail is explained here. And motion perception in action detects the movement of the real world using multiple sensors, and analyze and track the motion in real time, and predicts the future movement for the smooth representation, and renders the visual content accurately and instantly. So the motion perception makes an AR experience interactive, immersive, and real world easy. An application of motion perception in AR is as it also included along with the spatial perception. So integration of all these going to be creating the enhancement of an realistical mode in virtual or augmented world. It is used in the healthcare, manufacturing, automotive, gaming, and education. Surgical tracking and worker movement monitoring and robotic assistance and driver assistance and navigating systems and interactive AR gaming and then motion control environment and interactive simulations to the students to study about very accurately when comparing the spatial perception, the motion perception giving the in-depth knowledge of an study what we are going to take. And the motion perception in Industry 4.0 is improves the smart manufacturing, human-robot collaborations, and predictive maintenances and remote monitoring. And last one is actually a color perception, in which the color perception refers to how user visually interpret the colors, brightness, contrast, and lighting condition in mixed real and virtual environment. It creating the clear visualization, realistic rendering, better object recognition, reduced visual fatigue. In AR, color perception determines how the user perceive the virtual objects, real world environment, lighting condition, and display brightness and contrast level. So the various mode or importance of the color perception AR is the very important thing is it will creating a realistic visualization, improved visibility, and better immersion and user comfort and effective communication. Makes the virtual object appear natural in that, improves the understanding of the AR information, those importance is being there in the color perception. So, working principle of the color perception and augmented reality is similar to the spatial perception and the motion perception. It will sense the environment, but the thing is it doing the color analysis and rendering the adjustment and real-time display. So we need RGB camera, light and depth sensors, and for the color analysis we need ambient lighting, brightness levels, and surface colors and shadow conditions. For rendering, brightness and contrast, shadow matching is going to be taken care. And application is it's used in the healthcare, um, manufacturing, automotive and education. But the thing is, it will enhance one more time about the importance of the objects to be captured, because it will creating the differences between the real time environment to the virtual mode with the help of the color in identification. It also going to be useful for getting to creating the more realistic nature to when compared with various perception methods. And the technology support in the color perception is RGB colors, color capture, realistic lighting, and AI algorithm, computer vision. Along with the other things, it will using the HDR rendering and RGB cameras. And what is visual attention in AI? So up to that, the perception is covered. Next, we move on to the visual attention. So what is visual attention? So visual attention of the its ability, actually the ability of the users to focus on the most important visual information in the mixed real and virtual environment. So AR system guides and manages the users to attend with the knowing about the interactiveness between the objects to the real world. The AR system guide them and make an attention to improve the interaction, safety and test performance. So types of visual attention is selective attention, divided attention, sustainable attention and then spatial attention. In selective attention, focusing on one important object while ignoring the others. In divided attention, processing the multiple visual elements at the same time. Sustained attention, maintaining the focus on the task or object over a long duration. Spatial attention, focusing on a spatial location. And various working principle of visual attention is it will do many number of analysis to getting know about the interactiveness about the object to the virtual world, in the virtual world. The scene analysis, attention deduction, priority mapping, visual highlighting and real-time adoption. What is the scene analysis? The AI system analyzes the environment, object, position and user location in all the directions. At attention deduction, the system detects where the user is looking. And the priority mapping is important information is identified and given in the high priority. And visual highlighting, the critical content is emphasized using visual cases. The key benefit is better use of interaction, improved task efficiency, enhanced safety, reduced cognition kill, cognitive load or something, and increased immersion and satisfaction. And now we move on to that another topic which may be called as method of augmentations. So this refers to how digital information is integrated into the real world. It will be continued in the next session.